Welcome back to CarWow 787. If you're passionate about powerful diesel machinery, engineering excellence, and performance breakdowns, you're in the right place. Don't forget to hit the like button and subscribe if you haven't yet. Let's dive into today's in-depth look at one of the toughest diesel engines out there, the MTU V4000. From its reputation in marine applications to industrial power plants, the MTU V4000 series has become a symbol of robust, high-power diesel performance. Behind those heavy-duty stats lies a story of advanced engineering, precision manufacturing, and decades of refinement. In this video, we'll explore what makes the V4000 special: its architecture, technology, real-life specs, global applications, reliability, and what it means on the job. The V4000 is part of MTU's 4000 series, featuring versions ranging from 8-cylinder inline to V12 and V16 configurations. Today, we'll focus on the 12-cylinder V12 version, known for delivering 1,500 to 2,300 horsepower depending on the variant. That power range makes it a go-to for fast ferries, offshore vessels, power generators, rail engines, and heavy machinery. Let's start with the core, its engine design. The V4000 uses a compact, modular V12 layout, keeping the engine relatively short and efficient. Cast iron block and aluminum cylinder heads provide rigidity and thermal stability. It features 4 valves per cylinder and dual overhead camshafts, allowing high airflow and combustion efficiency. The common rail fuel injection system operates over 2,000 bars, ensuring precise fuel delivery and clean combustion, all while optimizing performance and reducing emissions. Turbocharging is handled by twin or sequential turbos, depending on the model. They're paired with cooled EGR and aftertreatment systems, meaning even with high emission stages like IMO Tier 2-3, the V4000 remains compliant. Its electronics include ECU-based monitoring and diagnostics, adjustable cooling circuits, and adaptive boost control. These features allow integration with modern control systems found in marine dashboards or industrial supervisory platforms. Moving on to some numbers. The V4000 V12 typically produces torque around 5,000 to 7,800 Nm at 1,800 RPM, and power between 1,500 to 2,300 horsepower. That torque curve is broad and flat, delivering usable torque through a wide RPM range, essential for pushing vessels through waves or handling heavy loads on land. With responsive throttle behavior and virtually no turbo lag, operators notice immediate power delivery when needed. Durability is another strong point. MTU uses forged steel crankshafts and connecting rods designed to handle peak pressure and torque. The block features integrated bed plates, improving stiffness and reducing vibrations. The cooling system utilizes twin-circuit cooling, one circuit for the block and a separate one for the heads, helping control thermal expansion and improving longevity. The aftercooler circuits ensure intake air stays at optimal temperature, enhancing performance in hot climates. From a service standpoint, MTU designed the V4000 with modularity. Components like the valve train, turbochargers, injectors, and water pumps are easy to access. Routine services such as oil changes, filter replacements, and belt inspections can be done with minimal disassembly, a major plus in industrial or marine environments where downtime costs are high. Speaking of downtime, onboard diagnostics (OBD) via the ECU allow mechanics to skim faults, read live data, and predict maintenance before failure occurs. Telemetry options can push engine data to fleet managers for remote diagnostics, especially useful on ships or offshore platforms. Now, what about fuel consumption? In marine cruising applications, the V4000 V12 uses roughly 270,350 grams kWh of fuel, about 190 to 245 grams per horsepower h, depending on load. That's competitive with engines twice its displacement, thanks to variable geometry turbos and high-pressure injection. In generator setups, fuel burn depends on the load profile, but with cylinder cutoff capability in newer models, efficiency improves during light load periods. One key factor in its reliability is oil and coolant circulation. MTU uses a dual-flow lubrication system with scavenge and pressure circuits that control oil temperature and remove debris. Coolant flow is optimized using electronically controlled thermostats, ensuring rapid engine warm-up and efficient cooling under heavy duty, ideal for mission-critical operations. Let's look at real-world impact. In ferry service, a pair of V4000 engines can push vessels at 30 knots or more, providing excellent acceleration and cruise speed. In power generation, they serve both prime and backup roles, depending on demand. In heavy equipment, such as mining haulers or rail units, their power-to-weight ratio and serviceability are major benefits. Fleet and service support is robust through MTU's global dealer network, offering parts, diagnostics tooling, and certified rebuild centers. When compared to other high-power engines like Caterpillar 3516C or Cummins QSK60, the V4000 offers similar horsepower and torque but often with lower emissions and less total weight. Its V configuration also provides a more compact design, which helps in space-constrained installations. Of course, nothing's perfect. The V4000's initial cost is high compared to inline counterparts. After-treatment systems add complexity and maintenance requirements. In remote or less serviced areas, obtaining genuine MTU parts may take time, though the dealer network covers most regions. Still, operators agree that for high-power, emissions-limited applications, the V4000 is a top-tier choice. Operators praise its sharp throttle response, with many saying response feels almost petrol-like. The engine sound, while deep and diesel gruff, is solid and confidence-inspiring, especially when to rumble into life together. Mechanics appreciate the accessible engine layout, quick oil and filter changes, simple turbo swaps, and ECU-supported diagnostics make a big difference when troubleshooting. Let's address environmental regulations. The V4000 is available in IMO Tier 2, 3, and Stage 5 variants. With SCR, DOC, and particulate filters, it meets stringent emission rules without compromising performance. Even in zero-emission zones port environments, the engine can run in silent mode during shore power operation, an important feature for modern fleets. Finally, its remanufacturing potential. The V4000 is designed with rebuild intervals. MTU provides reman kits for blocks, heads, crankshafts, and turbos. These kits often feature updated coatings, improved seals, and performance calibration upgrades, extending engine life and giving operators cost-effective refresh cycles. So who is the V4000 ideal for? Ship operators seeking reliable high-speed propulsion, power plant managers needing flexible, efficient power generation, and heavy equipment firms requiring compact yet potent power plants. It's also suited for retrofit programs where emissions compliance and space efficiency are priorities. In summary, the MTU V4000 is more than just a chunk of cast metal. It's an integrated system of power delivery, electronics, efficiency, and global service. If you're in the market for top-tier diesel performance, strong diagnostic capability, and long-term support, it's a leading contender. Thanks for watching this full breakdown of the MTU V4000 engine. If you enjoyed this dive into high-performance diesel tech, hit that thumbs up, subscribe, and turn on notifications for more inside looks at heavy-duty power systems. Drop a comment below. Have you worked with the V4000? Want to see a teardown, sound demo, or comparison with the Cat or Cummins? Let me know. Until next time, keep those engines roaring and keep chasing performance.